Some standard nth derivatives. As far as we have studied about single derivative, double derivative or maximum third derivative of a function, but we didn't study about the nth derivative of the functions, how to find the nth derivative of the functions. So now we will discuss some standard nth derivative, how to find the nth derivative of functions. Just like we are letting here, let y is equal to ax plus b raised to the power m, we will find its nth derivative. Of course, what method that we will use to find the nth derivative? The most prominent method is Leibniz method. But before discussing Leibniz method, we will first study a general method, standard nth derivative. So before studying Leibniz, we will discuss first it y is equal to ax plus. This is not Leibniz. These are some standard nth derivatives. So in this case, what method? What is this method? We find the first derivative, then we find the second derivative, then we find the third derivative. So these consecutive derivatives develop a sense what our terms are leading, what terms are going to a specific formula. These terms have a specific sequence. So when all these derivatives are converging to a specific sequence, then we will find the nth derivative, first derivative, second derivative, third derivative. So all these derivatives, first, second, third, fourth, these are interconnected with each other. So the first derivative, second derivative comes from the first derivative, and third derivative comes from the second derivative, and up to so on. So we will develop the connection. So what is the relation between first derivative and second derivative, and what is the relation between second derivative and third derivative? So after finding all these relations, then we will develop a sense, we will develop a formula. We will develop a formula, and that formula will be the standard nth derivative. So let me start. When we will do it, then we will understand the best how to find the nth derivative when without Leibniz. So let me start. Y is equal to, take the first derivative with respect to x, it will be just like y prime is equal to m into ax plus b raised to the power m minus 1, first derivative, and the derivative of ax plus b is a, and it will be m a and ax plus b raised to the power m minus 1. Okay, now we take the second derivative. The second derivative will be m into this m minus 1, and and this will be ax plus b raised to the power m minus 2, and derivative of ax plus b is again a, and so therefore here it is a, and it will be a square. Okay, now take the third derivative. When we take the third derivative, it will be m into m minus 1 and m minus 2. Therefore it will be a cube, because ax plus b, when we take the derivative of ax plus b, then it is again a, so a multiplied by a is a cube, and therefore it will be ax plus b and m minus 3. Okay, so now up to so on, yn, nth derivative, first derivative, second derivative, third derivative. So what is the sequence? What is sequence? Sequence is sequence of m is m, in first derivative m, in second derivative m into m minus 1, and in third derivative it is m into m minus 1, m minus 2. So it means that it will goes to m into m minus 1 and m minus 2, m minus 3, up to so on 1, 2, 3, it is m minus n plus 1. Why I write 1 plus 1? Because first derivative, and it is n, and this is our y. This is our y. So one term is more. So 1 n, and this is y. Of course, its power is 1. Its power is 1. So it means that there are total m minus n plus 1 terms. They are not m minus n terms. M minus n derivative means that m minus n plus 1. Okay, so here it will be ax plus b raised to the power m minus n. Okay, so this is our nth derivative, and if n is less than or equal to m, then we can write it nth derivative is equal to the nth derivative will be equal to, if n is less than or equal to m, it will be m minus it will be, this is equal to m factorial m minus n factorial, and you know this is a cube, and here it will be a raised to the power n. Okay, it will be a raised to the power n and nth derivative. So now it is ax plus b raised to the power m minus n. Okay, this is the nth derivative. So you can see there is a connection of all these derivative. From this connection we develop. Suppose if this connection didn't develop, then it is very hard to find this formula for the nth derivative. Okay, so now we see that if m is equal to n, if m is equal to n, then what it will be. In case of m is equal to n, our nth derivative will be yn is equal to, it will be n. So it will means m is equal to n means that 0 minus n minus n, 0 factorial, which is equal to 1. Okay, for m is equal to, so it will be n factorial, and yes, it will be n factorial. I am putting over here n factorial, m is equal to n factorial, and it is a raised to the power n, and you know ax plus b, m minus n minus n, which is 0, and ax plus b raised to the power 0 is equal to, this is equal to 1, and this is also equal to 1. So we only left this m factorial. Okay, so n derivative, so nth derivative when m is equal to n. Okay, suppose if I want to take, which is, this is a constant, if I take another derivative, means next derivative n plus 1, this will be 0, because this is constant, and that constant derivative, the derivative of a constant number is 0.